Hello my dear students, I warmly welcome you to CS digital class. In this lecture, we are going to discussing about elementary properties of the group, that is third elementary property. Okay, see the theorem statement. State and prove uniqueness of the inverse in a group capital G. Or for each small a belongs to capital G, there is a unique element small b in capital G such that, so we have to prove that a into b is equal to b into a is equal to small e. So therefore, this is the third elementary property of the group. Okay. So given that capital G is a group and small a belongs to capital G and there exists small b is a unique element in capital G and small e is the identity element. Small e is the identity element. Small e is the identity element in capital G. Small e is the identity element in capital G. Now we have to prove that claim inverse element is unique. Inverse element is unique. Inverse element is unique. Okay. To prove this condition, so I am taking two individual inverses of one element. That is, let B and C are the two inverses. Two inverse elements of small a. Okay. B and C are the two inverse elements of small a. Then according to the condition, if you take B as an inverse element, it has to satisfy the inverse condition. Okay, for A. So B into A is equal to A into B is equal to small a. That is taken as equation number 1. Next, if C is the inverse element for A, then for element also, so C into A is equal to A into C is equal to small e. It's taken as equation number 2. If you observe both equation number 1 and equation number 2, the identity element for both of the equation is same. Okay. So then we can equate that B into A is equal to A into C. Okay. Or we can equate that B into A is equal to C into A. You can equate these both of them. B into A is equal to C into A, or you can equate both of them, A into B equal to A into C. So now here by left cancellation law, okay, left cancellation law, by left cancellation law, if you take this value A into B is equal to A into C, then we can write B is equal to C. What are those B and C? B and C are the individual inverses of small a. Now what we got? Both are equal. So therefore inverse is unique. By right cancellation law. Okay. So by right cancellation law, so if you take this condition, that means B into A is equal to C into A. Then you can write B is equal to C. That means by right cancellation means this small a will get cancelled because it is a right side of each part of the equal. So therefore you can get B equal to C. By left cancellation law we got B is equal to C. By right cancellation law we got B is equal to C. So here B and C are the individual inverse of the element small a. So therefore inverse of an element is unique. So therefore inverse of an element is unique in a group capital Z. This is the third elementary property of the group capital G. I hope you understood this theorem very well. In the next lecture we are going to see another theorem. Okay, thank you.